The story you're about to see is real. Oh man! There's an Axelson lathe here, a Morris More speed, an old Johnson saw, and a Hardinge chucker. Well, this is what it looks like this morning. Let's get the key. My fingers are getting cold already. Let's see what it looks like in here. Oh, the heater's going. That's a good sign. Get the lights on here. Hey! Better in here, huh? Well, we're talking about this jewel here. And over here, this thing, 1951 Monarch 10EE manufacturing lathe. And it doesn't have a feed rod, I mean a lead screw. It's only got a feed rod. It doesn't cut threads, doesn't have a taper attachment. Very simple machine, but it has the magic Monarch spindle drive intact. Now this machine here, I got the manual and information from Monarch, and it was originally delivered to Bendix Aircraft Division in New Jersey, and then somehow it ended up at Hanford. It's got some Hanford tags on it. And it lastly ended up at Battelle National Laboratory in Richland or Hanford there. And they used it for a number of years and then surplused it in the 80s. And a local machine tool dealer got this. And then a gunsmith got a hold of this named Bernie here. And he couldn't fix the drive system, which was missing a little motor called the generator motor called the exciter. And it came with another motor generator that was either rebuilt or new, that was on a pallet with tags on it, and that's had some Battelle had that done evidently. But I knew some people that worked out there, and one of them remembered the lathe, and it was just something that was real handy. It got used a lot, and it's got a considerable amount of wear on it. And I got the parts needed. I'm trying to, it was 30 years ago, so when I got this. And I traded Bernie a really nice, probably the nicest I've ever seen, heavy tin south bend. It had the cast base and the honeycomb bed and all that stuff. And L-type spindle. It was quite a dandy. And, but anyway, that worked out for him, for his gunsmithing. And then eventually this worked out for me for working harder alloys and titanium and stuff like that that the hot rod guys needed. So I got it going way back then. I've been running it, and now I got to go through it. So it might be a good example of a machine that needs some work. There's a few things wrong with it. The bearings are going out in the motor generator, and it's just really loud. And also the switch here is a replacement. This is the starter switch, and I've been having to start it with a stick like that. Last few times I used it. This is a square D switch in there. Got a chip up there. I gotta deal with this and get the cover back on. It's got a square D switch in there, and the original would be a Cutler hammer, old time style square D. I'll go through this and see what's up. Now, this machine here, the 83, is a vacuum. That GoPro shut off again. I was talking about the newer machine here. The 83 is a vacuum tube design. It will run in your laundry room plugged into your dryer outlet 220. That's very, very simple. This machine here has a motor generator unit. You can see most of it here. This is an electrical panel, but it's a motor back in there. And what it is a three-phase motor driving a direct current generator, like those old torpedo welders. It's very much like that. Then up on top, it's got this exciter motor, and we'll go through that and clean it all up. It's running, but it needs bearings in this mechanical unit here. So you have to have a phase converter to start it. But once it's started, all the other controls are direct current. So we'll go through all that too. And this machine, for you Monarch 10EE guys, now chew on this. I'm going to point this out with an Allen wrench. Now, look at this right here that the tool post sits on top of. I think they did this at Battelle. But this machine has so much wear, that's an 80,000 step, that they had to lift it up with these pieces of steel here to get the tool post up to normal height of a machine in good shape. Isn't that interesting? I don't know how that works out, but the whole thing had to drop down 80 thousandths. The Gib rollers here have about an 80 thousandths gap, but the ones in the back are still contacting. So this whole carriage is like an angle. But it's an old lathe. And I know about all these things, and I can get around them. So that'll be fun to talk about too. Okay, I made it out here without a cup of coffee, and I'm gonna go get a cup of coffee. All righty? Hey, back inside here. It's like 17 degrees outside. Hey, I was checking out the eBay, and boy, I'll tell you what, these old Monarch 10EEs are going for quite a price. This old manufacturing lathe I have here wasn't worth very much money not too long ago, running and everything like that, but now it's quite a valuable thing. So I I'm kind of kicking things around here, and I was thinking I could show this machine like it is used, needs a bit of work, heavily used, needs just a little bit of work, runs, and a bit of wear and stuff like that. Just kind of look at it and kind of see a few things, you know, I could point out if you're going to spend that much money for one of these machines. And one of the things you have to consider too, I did a video. I bought that Axelson lathe out there from Yoder Machinery, I don't know, almost 3 years ago, I guess. And it was actually the least expensive geared head lathe. It's actual swing at 16, but it's a 14 by 30 inch. But it was the least expensive one on eBay, and it was like $3,200. And it came with a chuck and a couple other little things. But that cost, I did a video on it, and it cost $3,000 to tool it up halfway decently. Well, really quite well, I think, with chucks and things like that. Scramble it around, HGR, eBay, all this stuff, you know, that's not counting the time, $3,000. So if you're going to buy one of these machines here, you're going to be out, every bit that much. You know, it's just a smaller lathe and stuff. So that's something to consider. So this whole lathe here, I've had it around 30 years or so. And it's just worked and worked and worked and worked and worked. And when I first got it, I think I gave the custody, chain of custody on this whole thing. But it needed work, and I got it going. I did everything I needed to do, located an exciter for it, and blah, 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 blah. Got it going. It had a rebuilt or new motor generator, and I gave it, you know, grease the bearings and things like that on schedule. But after all these decades, it needs new bearings. And I'm going to start it up and run the spindle a little bit, and let's do that just for fun, okay? So the coil in the switch is not working. So let's try not to get shocked. Reach down here, and I'm going to start it with this stick. Okay, that started the motor generator, and you can hear those bearings are very loud. Let's have a look down there. This is the end, the right end. Okay, the exciter sits on top of the motor generator unit driven by that belt. Okay, let's start it up here. We'll get it in gear. Open belt. Don't want to start it too fast. There's an arrow on here. Okay. Fire it up. It's running right about 400 RPM, okay? And I'm going to throw the switch in reverse. Going to reverse it again. Turn about 30 RPMs, and now I'm going to throw it up into reverse and back, okay? This is pretty good chuck. I don't think it'll spit the jaws out. So I'm going to put it back in the open belt. Machine. So I'm going to shut it off now. Yeah, I got to fix those bearings on there. But I'm also considering right now boxing this thing up and sliding that Axelson in here and deal with this thing later when I move to a bigger place or have to expand this plate. So I'm going to think about that for a little bit. You know, I just might go ahead and move that Axelson in here. It's ready to go. It'll almost fit. Well, I hope you're all having a good day. So let's kind of have a look at this machine a little bit closer, okay? Now, I showed how much wear is actually on this machine and how it was compensated for to bring the tool post up to standard height, because the national lab that had this last had other 10 EEs, and then they could share the tooling, you know, so the tooling wouldn't be 80 thousandths too low when they want to use it on this machine. So that kind of explains that. But when you're looking at one, the place that's going to wear the most, let's see if I can kick the light on here. This is where you're going to see the wear. It's right here. This is on the inside. Let's zoom out. Then zoom in right here, and there's a ridge, and there's even a worse ridge, and it was so sharp I took and knocked it off with a file. You don't see much wear on this side. You see, it won't show there, but it's on this side, the small side. It's a thrust side. Okay, so you want to look there, but what I've done, and I've mentioned this before, is I found on this machine the sweet spots. So I have to take like way forward here, where it's just all this reversing and moving in, you know, working on stuff close to the chuck. It gets worn in these areas even worse. So you can I take like this extended tool holder, and even have the compound different and slide it even closer. Then I can get more accuracy of things in the chuck, avoiding the most worn part of the ways, okay? Now this machine, courtesy of the National Lab, before they surplused it, put new screws, new cross feed, compound, and a tailstock screw. And I really appreciate that. Thank you very much. So the screws on this are in excellent shape. And it's kind of typical of some Hanford machines. They kind of partially rebuild them. And I don't know the rebuild history of this machine, but I suspect that they may have ground the ways. I don't know, but they've definitely dropped down 80 thousandths of an inch wear on the carriage or whatever. Another thing that happened with this machine too was, of course, the tailstock. The tailstock was, what happens is people move these by the hand wheel, and I talked about that. It's very bad. You want to grab it down here and have a couple fingers up here and move the thing reasonably. If you reach under here, you'll find your hand fits under there perfectly, see? See that? Then you're not tugging on it, which causes wear to cause like this drill to point to the wall and downward. And this one was real bad. And what I did to fix it, instead of trying to change everything, I scraped the already worn ways on the tailstock base true to the worn out stuff that's left here the best I could. Then I propped this up on the milling machine table, turned some pins to put under the V here to bring this thing level, then skim the whole top, and then the whole thing shimmed up. That's what I had to do, and it works fine. And since I've had it, you know, moving the tailstock properly, there's no wear on it. So there's a lot of things you can do to make one of these, like this one, that's got considerable wear, do really good work. And I hope you enjoyed what I've shown that I've done with this high precision tool room model here, and the evolution of the tooling and stuff that I had to do to meet the work in my business. And it really worked great, just great. So I don't know, I'm kicking around just kind of holding off on this old manufacturing lathe and moving the Axelson in. So I'm going to kick that around for a while, you know. I don't know. I put so much work in that Axelson. Yeah, I just really want to get it in here and do it. I'm kind of getting the bug on that. So I'll think about that a little bit. But I can still use the Axelson to rough out parts before I put them on the toolmaker's lathe. But I just won't have the convenience of leaving it in the chuck. You know, see, I can put a piece of work in a chuck here and do the roughing, then move the whole chuck and work back over to the other machine. Now, that is a system that is common with Hardinge too, because they have the turn face bore lathe that does not thread, costs considerably less, and it's kind of like this lathe you hammer stuff on, and this is the one for perfection. And the reason I have this is for that bearing fitting, see? So that's the reason for this, and I showed you the evolution, I will call it, of the tooling I had to do to meet my customer specifications. Okay, kind of a fun video for me. Hope you all doing good, and stay out of short.